Okay, that was awesome. So obviously I made a mistake in that last video, and it just took me about 5 minutes to figure out what it was. I went back through every calculation there. Clearly it's getting late. It's almost 1 in the morning, so maybe I'm just need to call it a night. I don't know. Here's the issue. My sign's off. 7 times 2 times 3 is 42, but it's a negative 42 with that negative right there. So this originally should have been negative 42, but then you should change the sign to a positive. So I missed my sign on that 42. Should have been positive in the end. That would then make this negative 63 a positive 21, and then negative 77 plus 21 is a negative 56, which is what I was expecting to see. It just wasn't quite working out. It's nice to have already done this a different way. Okay, so then we know that d sub what is it? Yeah, d sub y can go through d sub y and d sub z. D sub y, again, I'm going to go through this quick and hopefully I won't miss another negative. So d sub y, I replace the y column, which is this column, with the constants 0, negative 7, 7. So it will look like 2, negative 2, 3, 0, negative 7, 7, and then negative 3, 1, negative 3, and then repeat the first two columns. So 2, negative 2, 3, and 0, negative 7, 7. Then we run our 3 diagonals in each direction. So that diagonal is 6 times 7 is 42. 2 negatives is positive. This combination is a 0, and this combination is another 42, positive. Going up, we have 9 times 7 is 63. It's positive. We have here 14, it's positive, and a 0. Then don't forget to change signs on top. All my signs should be correct. I tell you to correct me if I'm wrong, but you can't get a hold of me right now, so that won't work. Alright, on the bottom, looks like I get an 84, and on the top, it looks like I get a negative 77. Negative 77? Yeah, looks right. And so when I take 84 and negative 77, that should give me a 7. Yeah, that sounds about right. And then finally the d sub z, I'm going to go through and calculate that, replacing the z column, which would be this column here, with the constant 0, negative 7, 7. So this one becomes 2, negative 2, 3, and then 1, 2, negative 4, 0, negative 7, 7, and then repeat the x and y columns. So 2, negative 2, 3, and 1, 2, negative 4. Hopefully I'm not missing any negatives again. We're going to do our 3 diagonals each way. 4 times 7 is 28. 3 times 7 is 21, but here I've got to include the negative. That's a 0. This one is a 0. This one is 8 times 7 is 56, and it's positive. This combination is 14, and it's negative. Change the signs on the top, and then add them up. So on the bottom here I get positive 7. On the top Negative 56 plus 14 is a negative 42. And 7 minus 42 is negative 35. Okay. So that all looks great. Now I'm going to go through and calculate my final answers. This should be relatively quick. I'm going to do this right up at the very top here. So the x value should equal d sub x over d. We just found d sub x to be negative 56. D is negative 13. When I divide those, I just get 56 over 13. The y value is d sub y over d. D sub y we found to be 7. So we get 7 over negative 13, or negative 7/13. And finally, the z value is d sub z over d. We found d sub z to be negative 35. And when I divide that by the d, which is negative 13, I get a positive 35 over 13. Now that should, in theory, look like the answers we got doing this the other methods. 56/13, negative 7/13, and 35/13, all of which look good. Of course, I would put that in the ordered triple notation, but you've already seen that and I'm running out of room. The last thing I do want to mention about determinants and the Cramer's rule, actually there's two things. One is that it is possible to calculate this determinant D and get a 0 instead of another number here, like we got negative 13, but it's possible to get a 0. And notice, if you plug a 0 into these denominators, you would get an undefined value. Okay, anytime that happens, you have one of two situations. Either you have infinite solutions or you have no solutions. Unfortunately, Cramer's rule does not tell us which one it is. And so you would have to resort to a different method, either substitution or elimination or a calculator matrix, in order to actually solve those. So if you ever get a D value, this determinant of just the coefficients, to be 0, Cramer's rule does not work. You have to use a different method to figure out whether it's infinite solution or no solution. Okay. The other thing I wanted to mention is that your calculators can compute these matrices. That's how I just actually checked this one I made a mistake on, to make sure I was doing something wrong. And what I did is, just very quickly, I went into my matrix menu, went over to edit, I made a 3x3 matrix, and I typed in this 3x3 array of numbers. Okay, that's 9 numbers. I typed them in, and then so this is very similar to the RREF we looked at before, but if you go back into your matrix, go over to math, determinants are the first one. So you click that. I'll do it again just to show you. Then go back into matrix, grab matrix A under names, close your parenthesis, and you get the negative 56. So you can calculate determinants on here for 3x3s, for 2x2s, and for really any square matrix. Your calculators can give you those determinants, probably a little bit faster and more accurately than I did. Although it is very easy to mistype things in the calculator, so just be very careful. This is a very detail specific section. Take your time and don't do this at 1 in the morning like I am. Alright, enjoy your weekend, guys, and stay safe and stay healthy. Take care.